In this video, we're going to just go over the notes that we took on our second day of practicing equations that have variables on both sides. So in the 2021-2022 school year, this is page 15 in our binders. And I know that the numbers are a little bit off. This is the first example that we're doing today, but it says number 6, I'm aware. This equation says 1/4 x plus 17 equals x minus 4. Remember, when we solve equations, the first thing we do isn't actually math, it's just some organizational skills. We're separating our equation into a left side and a right side down the equal sign. Okay. Our very first step is to combine like terms. 1/4 x does not combine with 17 though. This has x's and this is a constant. Again, on the right side I have variables and I have constants, and those don't combine. So the first step is actually already done for us, which means the next step we can get started on. The second step is to collect our variables on one side of the equation. So our variable terms are this x, my pen work, it does, are the x and the 1/4 x. And we want to move one of the variables to the other side. That way all of the variables are on one side. So I'll go ahead and, I will go ahead and move the 1x, which is what I would assume most of you would do. So to move a positive 1 or a plus 1x, since we're moving it to the other side instead of combining it, we need to do the opposite sign. So the opposite of a plus 1x is a minus 1x. So on the other side, I write minus 1x underneath the term that also has x's. That'll help me know what to combine later. So now I've got a step down. We can draw a huge line to just keep organized. We did this on the right side, that way we would get rid of that positive 1x so we can move it to the left. That's because this makes a 0 pair. A number minus itself is 0, and 0 minus 4 is just that negative 4, so we don't actually have to write the 0 anymore. Now I have no x's on my right side. They're all going to be on the left, which was the goal of this step. Okay. On the left side, we've got a 4th x and minus 1x. Remember, we're going to ignore the x's for just a minute so we can write down the x. And our calculator does this next step for us. Here I've got the number 1/4, and then the coefficient here is an invisible 1. To type that in my calculator, I'll have 1/4 minus 1. So I see that's negative 0.75x. Negative 0.75. And of course I still have this plus 17 on that side. So our very first step was to combine like terms, which was already done. The second step is to move all of our x's or variables to one side. So I took them away from the right side and moved them to the left side. Now I have the remaining equation, negative 0.75x plus 17 equals negative 4. After all of our variables are on one side, we're going to collect the constants or the plain numbers on the other. Well, my variables live on the left, so I want my plain numbers or my constants to live on the right. My constants that are not on the right are 17. I need to move this plus 17 to the right side. The opposite of plus 17 is to minus 17. That moves it because that makes a 0 pair on the left. This is an equation. What we do on the left, we also do on the right. The 17's made a 0 pair, and we have just the negative 0.75x on the left side. On the right side, this is something you can type in your calculator. Remember, to type this in, you can do a couple of different things. You could have your negative 4 minus 17. You could also use negative 4 plus negative 17. Both of those work because in the term that has the 17, minus 17 or plus negative 17, there's only one minus sign. In front of the 17, there's only one minus sign. Something that would not work would be negative 4 minus negative 17, because that term has two minus signs. You can type in either one of those, and we can verify that right now that we do get the same answer. Negative 4 minus 17, or negative 4 plus negative 17. So we see that that sum, or that difference, is negative 21. Now we have all of our plain numbers on one side and our constants on the other. The last step before we have a value for x is to isolate the variable. Isolating the variable happens with a multiply or a divide. This says negative 0.75 times x. So to do the opposite, we'd have to divide. We want to divide by the coefficient to x. The coefficient isn't just 0.75. If you got rid of the 0.75, you'd still have a negative x. The coefficient is negative 0.75. So we divide by negative 0.75, and that gets rid of all of that. It makes 1. A number divided by itself is 1. So now we have 1x. On the left side, we divided by negative 0.75. We'll do that on the right side as well. Again, this is just a calculator part. We've got negative 21 divided by negative 0.75. You get 28. So x is 28. I want to skip 7 and 8 for now. Let's look at number 9. First, we split our equation into two sides, a left side and a right side. We are going to first combine like terms. On the left side, I have the constant 5 and the variable term 4x. Those don't combine. On the right side, I have a variable term and a constant. Those don't combine. So combining like terms again was done for us. Now I can go ahead and dive into moving variables to one side and constants to the other. The variable that most of you are probably going to pick is a minus x. To undo a minus x, you have to add x. If I do that on the left side, I do that on the right side as well. Write the add x underneath the term that has the x's. There's one step. So I am going to draw a huge line just to keep organized. That makes a 0 pair on the right, a number minus itself. And then I have my plus 20 remaining. We don't really need the plus 20. You can keep it if you want, but you don't need it. On the left side, we've got 5 that doesn't combine with anything. And then 4x plus, there's an invisible 1 there, 1x makes a 5x. All of my x's now live on the left, which means I want to move my plain numbers to the right. 20 is a plain number, so it's going to stay on the right. 5x has an x in it, so it stays on the left. 5 is a plain number. It needs to go to the right. This is a positive 5, since there's not a sign in front of it. I know it's positive. To undo that, we minus 5 from both sides. That's a step, so I'm going to draw a giant line just to keep organized. This creates a 0 pair on the left, and the 5's quote-unquote cancel out. What really happens is they make 0, and 0 plus something is just that something copied down. On the right side, 20 minus 5 is 15. Now our equation is 5x equals 15. The last step here is to, the last step here is to isolate our variable. Well, this says 5 times x. The opposite of multiplying some number by 5 is to divide those numbers by 5. If I do that on the left, we also divide by 5 on the right. 5x over 5, let's ignore the variable for now. Well, 5 over 5 is just 1. and 1 times x is just x. So we have an x on the left. On the right, 15 over 5, that quotient is 3. So we have x equals 3. Now let's go up to number 7. We'll start out by splitting our equation into two sides, a left side and a right side. First, we'll combine like terms. On the left side, I have a variable term 6x and a constant term 3. Those things do not combine. On the right side, we have the variable term 6x and the variable term minus x. Notice I did circle the sign in front of those numbers. The 6x doesn't have a sign, so we know it's positive. I need us to see that these are on the same side. When you have terms that are like on the same side, you just combine them like normal. So I've got a positive 6 and a minus 1. Ignoring the x for now, we've got 6 minus 1, which is 5. And I'm talking about x's, 6x's minus 1x, so that's 5x's. From here, I'm just going to copy down the rest of it. Minus 20. And that's one step, combining like terms. If I continue to solve my equation like this, I'm not going to have everything on the same line. So it's best practice to just write everything down on the other side as well. So just drop that expression down, 6x plus 3. Okay, so combining like terms is done. Now I'm ready to start moving variables, and then I can move constants, and then I can isolate. If you're following my advice, you're going to move 5x because it's the smaller amount of variables. To move 5x, you're minusing, because this is a positive 5x, you're minusing 5x from the right side and from the left side. I wrote the thing that has the x's underneath the thing that has the x's on both sides. On the left, 6x minus 5x leaves us with 1x, or just x, and we still have a plus 3. On the right side, 5x minus itself, any number that's positive minus itself, or any negative number added to itself, it's a positive version, that creates a 0 pair. So a number and its opposite make a 0 pair. And 0 minus 20 is just negative 20. You don't need the 0, in other words. Okay, after all of my variables are on the left side, that's where my variables live, then I'm going to put my constants on the other side. So my constants need to come over to the right. Negative 20 is a constant, so it stays on the right. 3 is a constant, it needs to go to the right. To get rid of a plus 3, we should minus 3. Remember to type this in your calculator. There are two correct ways you can use negative 20 minus 3 or negative 20 plus negative 3. Either way, you'll see that negative 20 minus 3 or negative 20 plus negative 3 leaves us with a negative 23. On the left side, those 3's made a 0 pair. X plus nothing is just x. The last step is to isolate the variable. Well, the variable's already isolated. There's no coefficient. The coefficient is an invisible 1, and 1 times x is just x. We don't need to rewrite that. So the answer here is x is 23. The value of x is negative 23. Okay, looking at number 8 now. Looking at number 8. We've got 6 plus 12x plus 36 equals negative 8.5x minus 40. We're dividing up our equation in between a left and a right side. We just draw a line down the equal sign to do that. The very first step is to combine like terms. On the left side, I've got a constant 6. That will combine with another constant, 36. Because they're on the same side, they're both on the left, we combine them like normal. 6 plus 36 is 42. And remember up here, I just copied everything else down, even the other side of the equation, just to make everything on the same horizontal space, so my work was really easy to follow. So I'll copy down the plus 12x. I'll copy down negative 8.5x minus 40 on the right side as well. There's one step. I'm going to draw a big line to just keep my work organized and easy to follow. From here, I'm ready to move all of my variables to one side. If you follow my advice, you're probably moving the negative 8.5x because it is the smaller amount. I haven't done any examples in this video where the x's end up on the right side, so let's go ahead and not take my advice and let's move the 12x. That's a positive 12x, so we're going to minus 12x to undo it. We minus 12x on both sides. Notice I'm writing the x's under the terms that also have x's because that's what they're going to combine with. That made a 0 pair on the left. 12x minus itself is 0. 42 plus 0 is just 42. In other words, you don't have to write the 0. On the right side, we can ignore the x's for now. Ignoring the x's for now, let's look at the coefficients. We've got a negative 8.5 minus a 12. Another way to write that is negative 8.5 plus negative 12. Regardless of which option you choose, you get negative 20.5. What you couldn't do is negative 8.5 minus negative 12, because this has two negative signs in the term 12. There's only supposed to be one. So when you combine negative 8.5x's and negative 12x's, you get negative 20.5x's. We have negative 20.5x's, and we'll just drop down the negative 40 there as well. The next step, after I have all of my variables on one side, is to move my plain numbers, or my constants, to the other side. So the left side will be my constant side. 42 is a constant, it stays on the left. Negative 20.5x has a variable, so it stays on the right. Minus 40 is a constant, it should be on the left. To move it over to the left, we're going to do the opposite of minus 40, which is to add 40. Now I've got 82 on the left, is negative 20.5x's on the right, and negative 40 plus 40 make a 0 pair. Negative 20.5x plus 0 is the same as just negative 20.5x. The next and final step is to isolate the x, which means I have to get rid of this negative 20.5. Negative 20.5 and x are being multiplied, so the opposite of that is to divide. Remember, we're writing division like fractions now. That's just fancy division, and we're in 8th grade, so we're okay with fancy division. If I divide by negative 20.5 on the right, I also divide by negative 20.5 on the left. Negative 20.5 divided by itself makes 1. So on the right side, all we have left over is an x, 1x. On the right side, the left side, we've got 82 divided by negative 20.5, which is negative 4. The lengthy part of this video is over. I'm going to kind of take the easy way out on the last two problems. I feel like we've done a lot of work with equations and you guys are pretty good at solving them. So we're going to look at two ways to write it that we've talked about before but haven't quite practiced. So let's look at the last two problems on this page. Number 10, we need to write and solve the equation model below. So in this model we see a scale or balance, and the scale's sides are both the same height, or they're completely balanced, so I know that this means those sides are equal. So my left side is equal to my right side. So let's go ahead and write the equation. We'll have a left side equal to a right side. On the left side, I have two bars that say x. To represent two bars that say x, we're going to write down 2x. On the left side, we also have 1, 2, 3, 4, 5, 6 little boxes that all say 1. So that represents a plus 6. So we have our variable blocks from the x's and our constant blocks from the 1's. On the right side, my variable blocks, there's 2 of them. So I have 2 of my variables, but they're negative. So this is negative 2x on the right. We also have 2 constant blocks, but those are also negative. So instead of writing a plus 2, we'll write a minus 2. And that is the equation. So 2x plus 6 equals negative 2x minus 2. This is an equation that you guys know how to solve. I'll have you guys probably solve that during class on your own. Looking at number 11. This says the perimeter of a rectangle and the triangle shown are the same. We want to write an equation to represent the situation and solve for x. Then find the perimeter of each shape. So what I know is that the perimeter of the rectangle, so this distance, that line, then that line, followed by this distance, followed by this distance, all of that, my rectangle's perimeter, is equal to, because it says the same, is equal to the perimeter of my triangle. This side plus this side plus this side. Perimeter is just the distance around. If I wanted to know what the distance around was equal to, you would just add all of the sides together. So we've got a 3x minus 0.5, a 5x minus 2. This side and this side are the same because this is a rectangle. So this side is also 3x minus 0.5. And then this bottom edge is the same distance as the top edge because it's a rectangle. So that's at 5x minus 2. So if I wanted to look at the perimeter, I'm going to take the easy way out here instead of writing a lot of overwhelmingly math things. Let's combine all of our variable terms from the rectangle. 3x, 5x, 3x, 5x. So we have a 3x plus a 5x plus a 3x plus a 5x for a grand total of, I typed in something wrong. When you type something in wrong, hit the go to button. I have 2 add signs. I forgot to put the number. So I've got 3 plus 5 plus 3 plus 5 for a grand total of 16 x's. So on my rectangle side, I know I have 16x. Let's turn that light off again. I've got 16x, and then I also have some constants on that side. We've got a minus 2, minus 0.5, minus 2, minus 0.5. So I've got my variable terms and now my constants. Bear with me just in case the calculator doesn't show up very well. There we go. Okay. So we have a negative 0.5, minus 2, minus 0.5, minus 2. All of that together is negative 5. So instead of writing, so we're going to have our 5 for our constants, and I'll write minus 5 because that's negative. That is all of my rectangle sides added together. Now let's do the same thing for the triangle sides. Let's get all of our variable terms, a 2x, 2x, a 10x. You can verify that 2 plus 2 plus 10 is 14 x's. And let's look at the constant terms on that side. We have a plus 3, minus 5. Again, you can verify that. You can verify with a calculator or your own adding that 3 plus 3 minus 5 is 1. So I have a plus 1. So my equation then is 16x minus 5 from the rectangle's perimeter equals, because the perimeters are the same, 14x plus 1 from the triangle's perimeter. To find out what x is, you simply solve the equation. So let's go ahead and solve this. I've got 16x minus 5 equals 14x plus 1. I want to solve for x. I'm going to move all of my variable terms to one side. I'll move the 14x. So minus 14x from both sides, written underneath the term that has x's, makes a 0 pair on the right, leaving over just a plus 1. On the left, 16x minus 14x is 2x, and then drop down our minus 5. All the variables live here on the left side, so we move the plain number, constant, minus 5 to the right side by undoing minus 5, which is plus 5. That leaves us with a 0 pair on the left side and 2x remaining. And on the right side, 1 and 5 make 6. To isolate x, we're going to undo the multiplying by 2 by dividing by 2. Because 2 over 2 makes 1, and 1x is just x. 6 over 2 is 3. So we know x equals 3. To find the perimeter, I just need to use what I know about x and plug it into either of my perimeters. We've been doing this in the previous days, not in this video, as our check step. We've been plugging in x, or 3, everywhere we saw x, and if both sides were equal, we knew we got it right because the two numbers were the same. But if both sides were not equal, we knew we got it wrong because obviously something like 0 equals 7 isn't true. So let's go ahead and do both sides to check our work. We've got 16, I'll put a bubble for x, minus 5. And then we've got equals, I'll move the camera over a little bit, 14 times a bubble for x plus 1. And inside of that bubble, we know, we think that x equals 3. So let's do 3 on both of those bubbles. Okay. And I'm telling you guys not to work any harder than you have to. Your calculator will do this. We have done so much math in this video alone. Our brains might be in overload, and that's okay. We have these handy dandy calculators to help us out, so let's use them. We've got 16 times 3. You can use the parentheses or the multiplication key. And then minus 5. And we get 43. On the other side, I've got 14 times 3 plus 1. We get 43. So that means I know I got my answer right. X was 3. X doesn't tell me much, though. What I need to know about these shapes is the perimeter. The perimeter is 43 units, because they didn't tell us how long each of those sides was. You'll need to do this part in class. Just summarize today's lesson. Probably 2 to 3 sentences sounds good. So we've practiced what we've been doing the past few days, and we also wrote equations using some new models. The homework is the next page. If you're in Ms. Blatcher's class, it's the next page on page 16. There's a problem very, very similar to this on your homework, so I would definitely refer to this example that we just did together. If you have questions, comments, concerns about the video or the content in this video, please don't hesitate to reach out to me. You can message me on Schoology or send me an email or talk to me in class about this tomorrow. Y'all have a great night.